Yeah.
Fab. Okay. So hi everyone, I'm Fiona. I'm an early career health data scientist at the British Heart Foundation Data Science Centre. And like you said, I'm going to be talking about the diabetes algorithm that we've been developing as part of the Catalyst over the last year and a half. So I'm not going to talk about the catalyst that was introduced at the last meeting, but just in case you forgot, one of the main aims was to evaluate how we can best define diabetes with the population-wide data that researchers have available to them. So we wanted to define a phenotyping algorithm that would then define a diabetes cohort or diabetes at population-wide level and the type of diabetes that a person has and their date of diagnosis. So before I go on to the algorithm, I'm just going to spend a few more minutes talking about that population-wide data that researchers have available to them because this informed a lot of the algorithm development. So if you're unfamiliar, there's many different areas and parts of the British Heart Foundation Data Science Centre beyond the Diabetes Catalyst. One of our main areas is called full population data, and this is where we're working with structured data or electronic health records, data that's collated at a national scale to do cardiovascular research. We have a project there called CVD COVID UK COVID Impact that drives most of that work, and the aim of that project is to understand the relationship between COVID-19 and cardiovascular diseases. And this is that project in numbers then. So we have a consortium with over 400 members. They come from many different institutions, and we have over 120 sub-projects that run under CVD COVID UK COVID Impact. So they're all projects that have their own specific research aims and questions, but of course they will relate to COVID-19 and typically cardiovascular diseases. There are some projects whose main aims and questions do relate to diabetes because we had a diabetes call for funding under the Catalyst. So of course they will want to define diabetes, but for many of the projects who are more concerned with CVD, they will of course want to define diabetes as well, given the close link between cardiovascular diseases and diabetes. A lot of them would want to define their cohort and then link define diabetes and have it as a risk factor in their analysis, for example. So how are the projects then defining disease? Well, they're doing it via data, a lot of data. So they have access to 3 national TREs, access to over 70 data sets. Their access to Scotland has momentarily lapsed, but they will have access to that again shortly. But 2 main things I wanted to point out here was they have access to data and a lot of it. So, and it's population-wide data. And if you have ever worked with electronic health records or indeed population-wide data sets, you'll know just how long it takes to bring these projects together. The underlying data sets are they're large, they're very complex, they take a while to get your head around. And the second thing I wanted to point out was that they don't have yet access to diabetes specific data sets. So they can't just define a cohort and then link to a diabetes audit, for example. They have to define diabetes, much like Becky was saying, using other data sets that they have available to them. And that's typically done using primary and secondary care. But for something like diabetes, of course, you would want to consider prescribing data as well. And that's exactly what our algorithm is doing. It's using primary and secondary care and prescribing data to define diabetes. And really what we're trying to do is accelerate research for those projects. So if a researcher or an analyst can come in and they can have diabetes already defined for them, they don't have to spend a lot of their time worrying about diabetes code lists in the algorithm, and they can move on and define other diseases of interest to them or spend more time on their analysis. And just one point another point that I thought of when Becky was speaking is the researchers, they have access to the 3 nations. And although they have the best of intentions to do their research across those 3 nations, what typically happens is they start in England, it's got the biggest population, and they run out of time because it is just so complicated to pull this research together, and then they don't then have time to take it into Scotland and Wales. So again, if we can define diabetes for them and other diseases for them, then maybe that would help them take their research into Scotland and Wales and be able to do a full 3-nation approach there. So that's the data. Before I talk about the algorithm, I did just also want to touch on something that Ewan mentioned and is how this came together. So it was very much a team science approach. It wasn't just an algorithm made by Ewan or the British Heart Foundation Data Science Centre. We had working groups that ran fortnightly for a year and a half. So if you were working in CVD COVID UK COVID Impact Project and your main project aims and questions were related to diabetes, you attended these working groups, and the groups reported on how they were getting on with their research, and that was great, really informed the algorithm development. And then as we were developing the algorithm, we took sort of key stages of it to workshops where we had a lot of clinicians. I think some people that attended them are actually in the call today. And we made decisions on key parts of the code list and the algorithm development there. Okay, so the algorithm I am going to talk through via an app that we've developed. So at the Data Science Centre, we're committed to open source and reproducible data science. So that means all the code that we develop inside a secure data environment or indeed outside, we put on GitHub. We want to be really transparent about the work that we do. But also, we have a lot of members in the consortium who are not analysts, so they might not be coders or programmers. A lot of them are clinicians or epidemiologists, so they might not code, or they might code and they might just not have time to go through screeds of code and script to understand algorithms. So this is the point of the app. We want to be very transparent about the process and document the development of it, the app itself, so that if a researcher or a new project in the consortium wanted to use this, they can quickly check the app and make an informed decision as if this is the right algorithm for them or not. So I'm just going to talk through a few key parts. I'll start with development. So it took over a year to develop this algorithm, and I think it can be split into two parts. So there's code list development and then the algorithm. I think you'd think the algorithm would take longer, but actually it's code lists, because there's just so many codes that exist for diabetes. So like I said, we were defining diabetes use in primary and secondary care. So we were considering SNOMED and ICD-10 codes, and we didn't just start from scratch. So we didn't start trawling through these sort of libraries because there's so many code lists that already exist out there. So we kind of exhausted HRUK Phenotype Library and Open Safely Open Code List Library for code lists, and we asked members of the working group if they had any code lists already developed that they wanted to bring forward for consideration. And I don't know if you've ever used the Phenotype Library. It's a fantastic resource, but if you type in diabetes, you're returned with 159 different diabetes code lists. So the question is, which one do you use and how are they different from each other? So with that in mind, we had over almost 700 SNOMED codes to look at and about 70 ICD-10 codes to look at for consideration. And this is how we've done it. So we use this app. Each row here represents a code and each column represents a specific code list or phenotype. We've done it for SNOMED and then ICD-10 codes. And you can very quickly see which phenotypes or which code lists include which codes and which do not. So two things we had to do. We had to consider which codes we would exclude and not take forward at all. And then also there was a classification task to be done. So we needed to consider what codes would be typed as type 1, type 2, other diabetes, and then not otherwise specified diabetes. We drilled a lot into the codes. We looked at code importance, code uniqueness, and I just wanted to touch on a key finding from this exercise. So we looked at this code, we discovered this code called Quality and Outcomes Framework, Quality Indicator Related Care Invitation. It's a really common code, so it's the top three here. So lots of people this is the prevalence of people that have this code within the NHS England SDE. A lot of people have this code, and it was used in 4 of the 11 SNOMED code lists that we source. So people are using this to define someone as having diabetes. What we discovered was a lot of people were being introduced to a cohort via this code only. So what that means is they only have that code and they don't have any evidence of any other types of diabetes codes. For something like diabetes, that is quite rare. That doesn't usually happen. So what you typically see is that they have the main type 1 or type 2 code, then they also have a handful of other codes for like retinopathy screening, foot examinations, for example. But in almost 20% of a cohort was being introduced via this quality and outcomes framework code. So we drilled a little bit more into it. we found that of those individuals who had that one code only, no other diabetes code, only 14% of them had a record of insulin, and only 2% of them had any record of high HbA1c ever. So that was one of the things that we took to one of the workshops, and we made a decision that that code should be excluded from our code lists, and we will feed back to projects who have already used that code and recommend that they take it out going forward. So I'll leave code lists there, and I'll just move on to algorithm development. Again, we didn't start from scratch. There's already amazing algorithms out there. Two that we knew were gold standards were one that were called an Open Safely algorithm. It wasn't actually developed in Open Safely. It was developed in Biobank by Sophie Eastwood, but then it was taken into Open Safely and adjusted there. That's when we discovered it, and that's why we've tended to call it the Open Safely algorithm. And it was also taken further into NHS England and adjusted again there. And then the other algorithm that we considered was the Exeter diabetes algorithm. So what we did was we took those two algorithms, we took them into NHS England SDE, and we coded them up there. You can see the flowcharts and table ones there, and we used that to inform how our algorithm would come together. So basically our algorithm, this is a flowchart of it, is a combination of Exeter and Open Safely with some parts of some steps tweaked, and we've added some steps in here and there based on the sensitivity analysis that we were doing within NHS England. I'm not going to go too much detail into it, but a few key points are the step one is if you have any other diabetes codes, you're straight away classified as diabetes other based on codes only. The sort of idea there was that if somebody has went to the extent of defining you as having other type diabetes, that's what you probably have, even if you have some record of type 1s or type 2s. We have this bit that ensures that if you're more than 3 years beyond your diagnosis and you've never been on insulin yet, then you would not then be typed as diabetes type 1. This part of the algorithm then sort of deals with the codes only, so looks at how many type 1 and type 2 codes you have to allocate you between type 1 and type 2. And then you get down to these discriminators here that bring things in like HbA1c and anti-diabetic medications. You can end up being unlikely, so you can go through that whole process and you can still you might be eliminated from the cohort in the end. So that's the flowchart, and we provide a table 1 of it, so you can drill into the table 1 via diabetes type or by each step, and you can use that to validate the algorithm. You can drill into age at diagnosis if you're interested, and that's by BMI and ethnicity. And then you can also compare how it performs to the Open Safely or Exeter algorithm. So to sort of validate this algorithm as we went through, what we did was we looked at the type 1 percentage in comparison to type 2 other, so the type 1 to type 2 other ratio. The reason we'd done that is because you can get that information from the National Diabetes Audit. So when we were changing steps of the algorithm, we sort of paid close attention to how that type 1 percentage changed. So under the NDA, that type 1 percentage is around 7, Exeter's around 3, 4, Open Safely is about 8, 9, and then ours lies somewhere in the middle. I'm not saying ours is correct, I'm saying this is expected given it is a combination of Exeter and Open Safely, that ours would be somewhere in the middle. And indeed, then you can make an informed decision as to what algorithm might be right for you and your research questions. We done lots more. We looked at reclassification. This looks really scary, but basically we reran the algorithm year on year to understand how somebody's diabetes type would change. It doesn't really change, so that's good. Even when you've got a whole extra year's worth of information, they typically 99% of the time stay the same type classification. You can look at it in a log scale if you want to scare yourself, but it's just to sort of look a bit more as to how people change year on year. And the last thing I wanted to touch about, well, you can also look at the sort of methodology and understand how we process the data, the limitations to our data, and any definitions that you used. But the last thing I wanted to touch on was how this was validated. So like I said, we kind of validated it as we went through with clinicians, people like you in, with Table 1, etc. But we're also really lucky to have that CVD COVID UK project, because we have 5 projects that are already using this algorithm. So that's great. They're already defining diabetes using this exact algorithm, and then they were able to feedback how they were getting on with that definition as part of their project. And really lucky, with thanks to Nick Thomas and Katie Young from Exeter, we are validating the algorithm using type 1 genetic risk scores. So we were specifically looking to try and maximize the specificity of type 1s, so trying to prevent type 2s being misclassified as type 1. This exercise is not finished yet, but we're using it to inform step 3 and step 6.1 of the algorithm. So, for example, step 3 will likely be changed from 3 years from diagnosis to 1, and step 6.1, we were using recency rules to distinguish between type 2s and 1s. So we were looking at what code was the most recent. But we're now considering ratios of type 1 to type 2 to do that. So I think 2 to 1, type 1 to type 2 is the most specific, but we're also looking to run it through 1 to 2 or 0.5 to 1. And last thing is, how are we encouraging adoption of the algorithm, especially within the SDE? Well, we're encouraging it by doing all the work, basically, for a researcher. So it's all coded up and it's running on a workflow such that researchers don't even have to look at the code if they don't want to. They can specify their job parameters specific to their project. They can point it to our GitLab, and they can choose the version of the app, of the algorithm they want to run. So we only have version 1 right now, but we're anticipating we might have a version 2 after that validation task that I just mentioned. And we are also typing it up in different languages because we use PySpark within the NHS England SDE to sort of take advantage of distributed computing power, but most researchers prefer R. So it's in 2 languages. And kind of wrap up there, but we do have next steps. We're committed to maintaining the algorithm, the versioning, evaluating code lists and data sets. And there's projects that plan on using it in Wales and Scotland. So Becky, it'd be great to look at your algorithm in Wales and compare. And yeah, I think there's also plans to have it run in Open Safely as well. Thank you so much for listening. I'll stop there.